And I'll turn it over to Pamela Dritt for the introduction.
All right. I'm Pamela Dritt, and I'd like to welcome you all to the Concord Area Humanist Virtual Monthly Meeting. As Andy said, we'll be recording it. So we want to ask you to please keep your audio muted during the presentation, but also feel free to ask questions and make comments in the chat window. And also after his presentation, we'll have a little discussion with our speaker, David Rose, who is, in addition to being a grandparent of 6 grandchildren, a developmental neuropsychologist who's taught educational neuroscience and universal design for learning at no less than Harvard's Graduate School of Education for more than 30 years, and also helped fund CAST, the Center for Applied Special Technology, a not-for-profit research and development organization focused on improving education by taking advantage of advances in modern learning sciences and innovative learning technologies. So without any more ado, welcome, David.
Thanks, Pamela. Let me just get my screen up here. Okay, I'm hoping everybody can hear me. Jim and Deborah, can you give me a thumb up if everything is all good? Okay. So I'm delighted to be here, and I'll talk for a while, and then hopefully we'll have time for some good sharing. So Mona Lisa doesn't need much introduction, so I'm not going to do much, but this is what happens when you go there. Some of you probably been to Louvre, and it's, by the Louvre's estimate, they told me they estimate that 80% of the people that come to the Louvre come to see the Mona Lisa ultimately, which is ridiculous. But at any rate, there it is, what it looks like in place. It's one of the most famous paintings in the world, certainly. Luckily, it didn't pay any attention to the present traumas because, in fact, it's her smile, like ours, that is ultimately very important. And so I wanted to just begin by talking about that smile because it's interested me and lots of people in the neurosciences to try to understand what it is that's made this painting so magnetic. And when you do scans, and I may get to talk about this later, of eye movement scans of what do people look at, they do indeed look very strongly at her smile. That is, a lot of their attention is, when you do the eye movements, that's where they go. So her smile's a big deal. But it's been hard for anybody to know what that smile says. Somebody did a review of what do art experts think that smile connotes. And you can see the words, everything from sly and ironic, magnetic, to enticing, wise, sensual, witty, sublime. You know, it's just an unbelievably diverse set of things that people think her smile is about. I want to talk about why is it so ambiguous? That is, why is there such wide interpretation of her smile? And also this enormous attraction to it, that we need to look at it. You almost can't not look at it. So I'm not going to summarize these, but there's been tons of studies, not like 5, but several dozen studies that actually manipulate and look at, in specific, how do people look at Mona Lisa's smile. And this is just one slide out of, they had 9 different images created of her smile to see which ones have that engaging quality and which ones don't. So these are done by pretty, serious, either art studiers or neuroscientists, manipulating her smile to see what is it about that smile that is so captivating. And just to show you that they're really out there, Neuroscience News came out with an article summarizing some of the research that said Mona Lisa's smile is not genuine. And neuroscientists are studying her smile. And that's partly why I want to talk about it, because why would neuroscientists care? You can see why art historians might. Anyway, one of the things that people have found out, not through this, but through other things, is there's really two kinds of smiles. And some of you may know this already, but the one on the left, now our president, wasn't when these images were taken, is called the genuine smile. But technically, people call it the Duchenne smile after the person who made this distinction. And it has some specific features around the lips and a cheek razor and a couple of other things that happen when you have the Duchenne smile. But there's another smile, derogatorily called the fake smile, which is a non-Duchenne smile. And it actually looks different. And you have to actually be kind of seeing a person do it to really catch the difference. But it's now well known that there are two kinds of smiles, and they have different neurologies. They come from different parts of the brain. Let's see, I've had a little problem in the print here. I want to talk a little bit about what the difference between these two smiles is. The Duchenne smile is what's called limbic, the emotional part of cortex that we'll be talking, and non-cortex too, that we'll be talking about later. And the non-Duchenne, the fake smile, is prefrontal cortex. They have different origins. The Duchenne is reactive. It really happens in real life. It's what people do when you say something warm and endearing, or they see a child, or they like you, or whatever. It feels reactive. Nobody's planning it. The Duchenne smile is, on the other hand, planful. It's what you do when the photographer says, "Smile, please." And I think you can all recognize, oh my God, that is not my best smile. In fact, we just had somebody photograph us today while we were hiking, and he had to try to figure out how to get us to do the non-fake smile, because we all look stupid when we do our fake smile. And you've been there, and photographers try to figure out ways to get you off guard so that they get your real smile, which is, you can say to them now, oh, you want my Duchenne smile? Versus your strategic, planful smile. And that's the prefrontal smile. And there's some other words here. It feels instinctive. It's part of our biology. Whereas the Duchenne, the non-Duchenne, the fake smile is intentional, something you do on purpose because you've been asked to or because you want to. It's cultural. You try to mimic what the culture does when it smiles. It's learned. It's unique. And I'm sorry about the typing here. I didn't notice that. It's what people call top down. That is, prefrontal cortex is sort of the highest part of the nervous system. And for that reason, people talk about it being your top-down strategic. I have a purpose in mind here. I'm going to smile. Whereas the Duchenne smile is, again, biologically built in. It's not strategic. It's not cultural. It's part of your basic biology of being a human being. So I want to talk a little bit more about the neuroscience part. And I just want to show you that real articles, there's plenty of them. This one's by Cortex, which is a pretty leading journal, of people trying to unravel why Mona Lisa's smile is so puzzling. But first I want to just say, did Leonardo actually do this on purpose? That is, make this smile perturbating and puzzling? Or was it just happened and it's an accident, and we're drawn to it in the way that we're drawn to other accidents? And so some of you may know this already, that Leonardo was an incredible anatomist and very early studier of medical anatomy. And he did a lot of, in his notebooks, there are drawings of him looking at the nerves that innervate the lips. He was very tightly focused on how do we move our lips when we smile and other things. So he did studies of it. So this was anything but an accident. He spent a lot of time figuring out what smiles were and how they are instigated by the nervous system so that he could paint them. And so in his own way, he certainly wouldn't call it Duchenne smiles. He really knew the different kinds of smiles and how muscles, how our nervous system uses muscles to make those smiles. And it seems relatively clear that because of all that, that Da Vinci wanted her smile to be ambiguous. That is, it wasn't an accident at all. He knew what he was doing. Another thing that shows us that, other than his notebooks, is that he worked on it for years, not days. I think some of you may know he traveled with it. This painting was very important to him too. It wasn't just like he tossed this off and the world later liked it. It was a very important painting to him. And he worked on the smile, and they see layers of it that he was meticulously trying to get what he got. So this was not an accident. And in some way, although he wouldn't use anything like these words, he wanted it to be at the, what's the intersection of these two kinds of smiles. So you couldn't tell, is she being strategic, i.e. posing for the painter, or is she actually smiling? And he wanted to play with that ambiguity because it had meaning for him. So that's a bit of what I want to say. But that ambiguous smile, I think quite intentional by Vinci, is part of what makes the portrait so engaging, so disturbing, so captivating. I realize that I probably won't have time to come back here, but I want to be clear that he does a lot of other things, the smile being the sort of most noticeable. But if you look at this painting, look at the backgrounds on the left of her side of her and the right side of her. You'll see that they actually don't line up. Now, remember, he spent years doing this. So not noticing that his background isn't, what's the word, isn't perfectly aligned, didn't happen by accident either. That he actually did that for reasons that art historians talk about, to get a swoop of movement into this painting, draws you in this sort of exact way he wanted to draw you in, right to her face and so on. And so he said, I don't care if the background's exactly straight, I'm going to manipulate it so that the background too is ambiguous, which is, you know, pretty interesting. Okay. But for most people, this painting, and in fact, indeed at the time, is also beautiful. And I want to talk not about just what pulls us in about the smile, but really what makes this painting beautiful. And I want to start at the end. For a neuroscientist, this is what makes it beautiful. This is an fMRI, a brain scan. Some of you have had them. And there's a part of the brain that lights up, unquote, I'll explain what that means, when you think you've seen a beautiful painting, okay, or a beautiful object. And there it is circled. We'll talk about where that is in a few moments. But it's a strong effect. When you say it's beautiful, that part of your brain lights up. So what does lighting up mean? Lighting up is just, it shows up on the screen, the computer screen. But what the scanning devices are mostly measuring are the amount of activity that's happening. And that is revealed by the amount of oxygen neurons are taking up, or the amount of blood they're taking up. So you're just really measuring how much glucose and oxygen and blood is being used by that particular part of the brain, showing that it's intensely working. There's something very important that the brain is doing with that part to show up like this, burning a lot of oxygen, and nutrients and so on. It's firing like crazy. That's a little bit of an exaggeration, but it's noticeably different. So what people found was that this area that we're going to talk about really has a burst of firing when to something that you later describe or at that moment as beautiful. Okay, so why this part of the brain and what does it mean? That's what I want to get to. First, I want to provide some context about the brain. Some of you probably know as much about the brain or more than I do, some of you not very much. So I'm going to do a little bit of kind of trying to hit the middle here. So here's a brain, and I'm going to divide it into 3 parts. And that's all you need to really remember is 3 big parts of the brain. In the back part, circled in red here, are what I'm going to call posterior recognition cortex. And a lot of people don't realize this sort of very simple thing. The whole back part of your cortex, but also your spinal cord, your thalamus, every part of your nervous system, the back part is really about one thing: taking information in and making some kind of sense of it, recognizing it. Wherever you look in the nervous system, the back part of your brain is taking information in and making, recognizing it, making sense of it, making knowledge out of it, and so on. It's a very simplifying kind of way to see the brain. So the back part is what I want to talk about first. And the classical view was that one of those parts is vision. And this is what it looks like when you show something and ask someone to look at it. The occipital visual cortex lights up, use a lot of energy because it's trying to understand what it is. Okay, so occipital visual cortex lights up. But to neuroscientists and artists too, people, this is a good quote, people are wedded to the idea that colors are properties of objects when they're in fact made up by the brain. Actually, colors don't exist in the world. Your brain makes them up, and the same with sounds and all kinds of things. That your brain is constructing a model of the world, and it does that like this. It specializes. It's really pretty simple. It colors in one place, shapes in another, faces has an area that lights up when you see a face. On the left side, when you see movement, another part of your brain lights up, but they're all in the back. These are the sort of parts that go with vision. But anyway, vision specializes and says, we're going to take many different sets of information from whatever's out there and construct faces, colors, shapes, sizes, distances, movements. We're going to construct inside the brain. So you're mirroring the outside world, saying, I'm going to make that thing inside my brain. And it's a constructive act. It's not a receptive one. Okay. And it specializes really even within vision. That is, and by the way, people will differ on this, but there'll be an area that will specialize for recognizing words that is different, although nearby to the area that's specialized for recognizing faces or buildings or so on. That there's really a nice mapping to say, we're going to specialize this part of the brain for facial recognition. And there's one other thing I want to say about this, because the old view was that something like looking at art was a bottom-up thing, that it kind of comes in the back of your brain, and first it's shape and color, and then it's objects and faces, and then it's whole scenes, and it's getting more and more complicated. So a bottom-up view starts literally with your cones and rods, and it ends up being Renaissance paintings. A bottom-up view starting in visual cortex and getting more interesting. And some of you know this, there's 2 main pathways. One is to help you understand what the object is, whatever's in front of you. And the other pathway is, where is it? Of all the world out there, where is your cell phone? The new view of the way the nervous system works is really very different and says, no, that's not the way it works at all. It's a reciprocal network It's not a linear chain of any kind. It's not a computer program in that sense. It is a network, and there are reciprocal connections between all of the parts, and your things are embedded in rich networks, and they all play a part in what you recognize. So you don't start with color all the time, and we'll show what I mean, and build up to other things, but you often start top down or sideways with expectations that will influence what you see. So you remember this dramatic example of this where people had different interpretations of the color of this dress that just appeared on the web, and it became a viral sensation. So some people, you're out there, and some people saw it as black on blue, some saw it on gold and white, and it was extraordinary when people had the conversation. It was discovered by accident. It wasn't a research thing, but people talking about it. Somebody said, "Boy, that blue dress is fabulous," and someone said, "Blue dress? What are you talking about? It's a white dress." And they said, "What are you talking about?" And anyway, and then they shared it with their neighbors and friends and realized, some big proportion saw it as one or the other, and so on. Some people see it as gold and light blue, and so on. Why is that? Well, it's because it's not bottom up. The reality is that your brain is taking a lot of information in that's not just about the dress or the colors. It's taking in, is this artificially lit, or is this out of doors? And the picture's ambiguous about that, to get to ambiguity again. You can't really tell whether she's on the porch and it's sunlight, or she's in the house with a window behind her. And that is the criteria factor for how people see it, because your brain, in this beautiful network, one part of your brain is figuring out, are we inside or outside? And it's telling the visual cortex that reading color of dress, this is inside. Oh, interpret it correctly for inside or outside, okay? And so that's how the brain works, these incredibly beautiful networks that allow you to have what's called color constancy under different lighting conditions. And this one just happens to be ambiguous in terms of context. You're not sure what it's in, so some of you go wrong one way and some go wrong the other way, okay? So that's the way we think of the nervous system now. And that'll come up a little bit later in something I want to talk about. So when you look at the Mona Lisa, this back part of your brain recognizes all the colors and shapes and stuff, recognizes her face in a different place, the face area, and her smile in a different place, that it's an Italian landscape, that it's a high Renaissance style. All of those things happen here in the back cortex. But they are not bottom up only. If someone tells you this is a high Renaissance painting, it actually starts to influence how you'll see colors and shapes. It's just as much a downward thing as an upward thing. And if someone tells you her smile is this kind of smile or whatever, so that you're going to make your best interpretation, not bottom up, just given colors and shapes, but all of what you know about a Renaissance painting is taken into account to give you a sense of who is this, okay? A key thing for today's talk is it doesn't recognize that it is beautiful. It recognizes her and her smile, and it's a Renaissance painting and all of those things. The classical art view was that beauty would go with the vision, would go with all this part we've just talked about. So classical architecture was inherently beautiful because it is. It has perfect proportions and things like that. The Parthenon is beautiful externally. So a new view is much more sense that this actually really helps you understand the Parthenon, but nothing here lights up to say it's beautiful. Okay, are people with me? Is that clear enough, I think? Okay, so the beauty is going to come from somewhere else, and it's not part of visual cortex. I'll go a little faster in the next two things. Let me check my time. The next part of the brain is in the front. Completely different part of the brain. It looks different when you look under a microscope. And it is strategic and motor cortex. It allows you not to, the back part takes information in, the front part allows you to express yourself, to move, to jump, to shoot basketballs, to talk, all of those things. It's about how do you affect the world? And since we're higher mammals, how do we smartly interact with our world, acting on it? So front part's different. It's not about taking information. So one question is, does that have anything to do with recognizing beauty? And I'm going to go quickly here just to say, actually, if you measure someone looking at a work of art, motor cortex does light up. And that was a surprise to find that, in fact, there's something motor going on when you're looking at a painting. And in fact, this is one of the studies, I'm not going to go into deeply, but they asked people to look at the movement in the hand here. And you see the two graphs that the brain in a specific part of the cortex, motor cortex, lit up more because they were looking at something, though completely static, represented movement. And some of you know about mirror neurons and all of that. So that's something we now know, that your brain is trying to mirror movements. So you recognize and understand movements by mirroring them, sort of playing them out with your own motor cortex. So when you look at a painting that has movement in it, your motor cortex is trying it out, is literally simulating the movement, especially if you see something like a dance. But more importantly, for what we're going to talk about, is way up front, the kind of goldish color here is prefrontal cortex, the most lately evolved and the latest developing in children, prefrontal cortex. You probably all heard of prefrontal cortex. But I want to talk about its specific role. When you look at this is a famous study. Forgetting his name, Yarbus, took a painting and let people look at it, and he studied their eye movements. And the interesting part, well, I'll show you what their eye movements look like. Here's what the eye movements look like. Now, the first thing you notice is they're really different. Why are they so different? The answer is because he asked a different question. Each time he would say something like, is there a cat in the room? Are these people related? Okay. What's going to happen next? It has a whole series of questions. And people very carefully looked at different parts of the picture to help them answer such questions. So it was intentional and strategic ability to say, oh, if he's asking how are these people related, I'm going to look at their faces. And you do. And if you're on the left here, if it's, is there a cat in the room? You sort of go, I better look anywhere. That cat could be hanging from the ceiling. So you have different strategies according to the question. For something briefly I want to touch about later, what happens if you don't have prefrontal cortex? And here's what happens. It doesn't matter what question you ask. The person looks at the painting in the same way. They are not driven by their own goals, their own strategies. They're in fact bottom up, driven just by the painting. They just look at the painting randomly. So that's, again, that top-down thing. Most of us, when we look at a painting, are doing a top-down. We're looking at it for a reason. We want to know, what's the artist doing? We want to know, do I like this? Or this looks like a earlier Cézanne or whatever. We have purpose when we're looking, or you're just trying to understand what it is. But you intentionally do some top-down stuff, which determines what kind of motor movements your eyes actually make. So you both have automatic eye movements, and you have these very intense. Okay, so turns out the front part of your brain is part of how you look at a painting, and it's very important part, as it turns out. In fact, part of why you sometimes say I was moved by that painting, because in fact, if you look at your brain, it was moving. It allows you to move with the art, investigate it, interrogate it, as everybody says now, and so on. An active grasping motorically onto the painting. But again, this part of the brain also does not decide if it's beautiful. Nothing specially lights up in this part of the brain when something later you say is beautiful. strategic, very important in getting to beauty, but it's not where the decision that this is beautiful comes from. So just checking my time. We're doing okay, I think. A third part of the brain, if you see that top part is the outside of the brain that we've just looked at. We looked at the back part, now the front part, then the front part. Now we're going to look in the middle of the brain, the bottom half of this image. That middle part is, we've had to take it, cut the corpus callosum, cut it apart, and you can see, this is what it looks like on the inside, a drawing of it on the inside. And here, yet a whole new thing is what the brain concentrates. It's not on taking information in. It's not about making actions on the world. It's about making what most people would call affect, valuing things in the world. And everywhere in the nervous system, all the way from the spinal cord up through brainstem, through cortex, there's parts of the brain that are about determining, how important is this? What's its value to me? Should I be doing even this reflex now or not? It's not about your ability to have a sense about the reflex or be able to move, but it's about, should I let that reflex go? Or should I make any movements? Should I be investigating this painting, or should I go on to another one? So this middle part of your brain, it's all about valuing, and it's critical to everything. It's what ultimately makes us really smart, that we value certain things to look at and certain things to do. We don't just willy-nilly go through our world. So if you can think about values, now we experience disruptions in values, either positive or negative, as emotion. So you could also say this is emotional brain. And a lot of people do call it limbic emotional brain, because emotions are what we feel when something is really important. And that means, as you probably know, the amygdala lights up like crazy when you see something about which you are afraid, something that frightens you. Areas in the middle of your brain light up intensely to say, okay, this is its value. It's frightening. We need to get away. We need to escape. We need to fight, fight or flight, all those things. Different kinds of importance. And others are, this is really good. I want more of this. And I'm going to sometimes call this medial cortex. Does this play a critical role in art? And I'm going to just take a moment to talk about the chemistry here. There's a major chemistry track that runs through all of this, to a couple of them, dopamine and serotonin. I'm not going to talk about serotonin, whole nother talk, just dopamine. And if you see here this kind of little thing about dopamine, what's dopamine doing? Dopamine is released, and this system fires when something good happens that's a reward. You get food or sex. Dopamine is released. Say, let's do that again. Or remember where we are, because we might be able to get this back again. Or, a pigeon, peck that again, you might get some more food. So this part of the brain is about valuing, saying it's important to do that. Or alternatively, it's important to get away. If you saw a lion there once, it says, remember that. Dopamine will say, remember that lion was right here by the river. So that next time when you come to the river, you go, oh, brain says that's important to remember, important. And we used to call it now print. We don't do that anymore. But anyway, dopamine says, learn this, anticipate it. So next time you come to the river, you won't go near the lion. So that next time you see that beautiful woman, you'll go up to her and talk to her again. Sorry for the sexist remark there. Anyway, serotonin, different. This is what it looks like, this reward circuit, they used to call it. Now we understand it differently. Certainly it is the part that gets excited when a reward, positive reward happens. It too is both bottom up and top down, as I'll mention in a moment. And you can see where this arrow goes. It goes up to the very front of the brain, and a specific part of prefrontal cortex that I'm going to call orbital frontal cortex. It actually has several names, but this very specific part of prefrontal cortex that gets rich connections from dopamine and from the reward. And I'm not going to talk about the negative ones for the moment. And there's orbital frontal cortex right there. And that is the part of your brain that calculates the values of things. And they can be negative values, positive values, but it's really different. It's not what is it or what I should do, but what is the value of this thing to me? And where does it get its input? It gets a ton of input from all of those recognition cortex things I've talked about. It gets input from what your goals are, prefrontal cortex, get input from huge, all kinds of parts of the brain, send input to orbital frontal cortex. So it can make a good judgment about the value of things. Because as you can tell, the value of food can be very different, whether you're hungry or not hungry. So it has to be measuring. Have we got enough food here? Okay. And you don't always want to have sex because sometimes it's completely inappropriate. So you've got to know what's the context and who are these people and so on and so forth. So it's got to be taking a ton of information in to say right now, food is important, or it's more important for me to breathe, or it's more important for me to study or whatever. All those values are calculated here. I'm not going to talk about it, but, well, no, I won't talk about it. Anyway, just for a moment, music instead of art. If we hear music that meets or surpasses our expectations, that is, we really like it, part of this reward thing will fire and release dopamine. Just music will do it. A feel-good chemical that's generally awarded with associated with rewards, like the feelings we get from great food, great sex, or drugs, unfortunately. This is the seat of addiction as well. But this, here they called it medial prefrontal cortex. Unfortunately, the naming of things is rough, but we could say orbital frontal cortex here helps us attend to the value, attends to the value to attach value to abstract things like art and music. Wait, I'm sorry, I got to get rid of your pictures because I can't see my own slides. I want to just point out the abstract things like art and music, not food, not sex, not drugs, abstract things, because orbital frontal cortex gets its great information from everything. If a song depresses you or makes you bounce around the room, the amygdala, a lower structure, there's some of the blame. If you spend $12 million on a shark suspended in formaldehyde, blame the medial, or I'll say orbital frontal cortex. In other words, if there's some abstract piece of art that you're willing to pay a fortune for, or you're willing to drive across town or go to the Louvre to see something completely abstract, that's going to reside mostly in orbital frontal cortex, not down in the amygdala, not in the ventral tegmentum, not in any of these areas lower down, but orbital prefrontal cortex, which has got a lot of information about where you are, what's happening, what's going on in your life, and some other things that we'll get to are part of what's in orbital frontal cortex. So it is where you can like things like art. Let me see my, and there are lots of articles like this. I just wanted to show you one so you won't think I'm just making all this up. But people wanted to know, is the intensity of beauty related to the intensity of pleasure, of those pleasure circuits? And the answer to in their survey of all the literature, the line near the end, thus both general and anhedonic results, those are people who don't have pleasure, support the claim that intense beauty requires intense pleasure. So this is part of the argument that part of what orbital frontal cortex does is its key attachment to that pleasure network. All of those things that have to do with rewards and things that we find pleasurable. Orbital frontal cortex is like a head ganglion for all of that, to bring all that together with all of the things that we've just been talking about. But the intense pleasure is part of what makes something beautiful. And that is the first picture I showed you. And it is, in fact, orbital prefrontal cortex that lights up when you call something beautiful. And they've done all kinds of studies. And you just ask the person, look at these paintings, tell me when you see one's beautiful, just one way to do it. And then they just measure what happened in the brain. And what lights up on the trials, they said it was beautiful, is orbital frontal cortex, right where the circle is. Lots of studies are in different ways. Here was a big surprise to neuroscientists, and I think artists and musicians too. It's exact, I flipped these images, I apologize for that. The same area lights up when you say a piece of music is beautiful. People did not expect it. And I want to highlight what's important about it, because it really shows that the beauty is something that's very different than something that's happening in visual cortex. The Parthenon has hit your visual cortex or something. Beauty is constructed way up here, and beauty is its own thing, like color, like motion, that a part of your brain is specialized to respond to. And it doesn't matter, that's not true, but largely it's the same, whether it's musical beauty you're talking about or visual art beauty. And in fact, I've done, lots of homework. And I know that some of your people that I know have seen that, in fact, when you describe a meal as beautiful, this same part of your brain lights up. Doesn't matter whether it's something you eat, something you look at, something you listen to. If it's beautiful, orbital frontal cortex is most likely where you'll see the intense burning of glucose and oxygen processed there in the brain. I want to end by talking about, well, what makes orbital cortex light up? What is it about art or music or great food that makes it get intensely lit up? And in a much longer talk, I would say there's whole things about the biology. That is, the anatomy matters. Some people have a larger amount of their cortex devoted to orbital frontal cortex, or a larger reward circuit, and so on. And they respond differently, either less or more intently to things as beautiful, just by their anatomy. Same with chemistry. I'm trying to think what would be a good example. Since a lot of us are older, you probably have friends who have Parkinson's disease. And there's a phenomenon that's been well reported by lots of people, that a lot of people with Parkinson's disease seem to become much more artistic, both loving art and creating art after their onset of Parkinson's disease. And people were puzzled by all of this, and then did studies and found out, of course, same part of the brain. But what's happened is not the Parkinson's, it's their treatment. The treatment for Parkinson's is to give people precursors for dopamine. So in fact, their brain has more dopamine going in it. And so they have a more intense reaction to beauty and a more high desire to create art. Fabulous stuff. So chemistry actually does make a difference. And as you know, drugs, we can stimulate high dopamine drugs and you find art more beautiful. I hear some of you used to smoke marijuana, and you've seen that phenomenon. Physiology, I think I'll just say quickly, among other things, if you stimulate here so that it doesn't operate right, it's a technique to sort of deaden the brain without damaging it. And sure enough, people don't find art beautiful if you stimulate there. It's like it disrupts their ability to sense the beauty. And people differ genetically. Some people have much more intense, pleasurable circuitry and more intense sense of beauty. The part that's more interesting to us, probably, there's a lot of that. And I'm sorry, I had to cut out sort of most of the research on that. But there's a lot of other things, though, because of how those enormous connectivity, the top-down connectivity of orbital frontal cortex, a lot of other things make a difference in what is beautiful, or as a neuroscientist say, what makes orbital frontal cortex fire up. And I'm only going to do a couple of these just to give you a flavor for it. Remember how I talked about in the dress, context matters. Your brain is always taking context into account. Is this an internal room or an outside room? And context matters to whether orbital frontal cortex will light up, will experience things as beautiful. So for example, you're much more likely to have orbital frontal cortex fire up if you see a painting in a museum, because your brain takes in the context, say, oh, we're in a museum. There are beautiful things here. And so you're primed. You're ready to have an experience where you see beauty. And there are studies showing, this one showing that the exact same painting shown on a computer screen or in a gallery or in a museum, your orbital frontal cortex lights up more if you see it in a museum or a gallery than if you see it on your screen. So if some of you are art dealers, that's why people don't buy the art as well off your screen. It doesn't look as beautiful. This top-down thing is really extraordinary in that it isn't that you start with the Parthenon and build up to beauty, that in fact, sometimes you start with the museum and really do a top-down thing to say, this is in the museum and it's art, and I better look at it with prefrontal cortex, and it maybe is beautiful. And this is Malevich's, the first sort of famously completely abstract painting, just called Black Square. Just a black square. That's all it is. It's been, this cracks you see are the cracks in the paint. It wasn't what he painted. So Malevich's painting is $1 jillion painting, and its beauty was entirely conceptual, entirely a part of knowing what art is and what art was and where art is going. And only a few people saw it as beautiful at the time, but they were artists. They had a great experience with art and so on and so forth. Top-down thing, realizing what Malevich was doing was an important thing and a beautiful thing. And context actually mattered. This is what it looked like when he showed it. Someone's recreated it. He put it in the most dominant place in the show to say, this is something different. You know, it's at an angle and it's in the corner, because he wanted to light up people's orbital frontal cortex. Odd enough that it was a black square, but it's also even placed oddly to say, look at this. And some people just went, wow. And some of you know this probably, I didn't review this before I got together, but to show how context matters completely. This is a work of art that showed, I think, in Italy, pretty sure, and it was called, I'm sorry, I apologize for not labeling, and it's called like After the Party or something, and a very carefully constructed artistic artwork. And people, you know, wrote reviews and said, well, how imaginative, whatever. Anyway, unfortunately, the museum closed that night, and the cleaning people came in, not being alerted to the fact that this was a piece of art, but looked like a messy party had in fact happened, and they cleaned it up, destroying the art completely and so on. And they had to carefully recreate the whole thing and warn the cleaning people that this was art, not a mess. But it shows that top-down thing, that the people who came to see it were of two sorts. The people who came to see it as art came with a very different lens, and some saw it as very beautiful and some saw it as very much an advance in art. The people who came in as cleaners saw it as a big mess that needs to be cleaned up. Top-down effects. Just some other quick ones. People have done studies to show that it matters to orbital frontal cortex and to your sense of beauty what the title of something is. Titles actually matter, and that's why museums do them. And it matters what you're told ahead of time, because that's a top-down thing. Someone says this is in this case, a diagonal freeway, it alerts you to how to look at it and makes the looking of it be somewhat special and idiosyncratic for you, your interpretation of what that would mean, and so on and so forth. And other factors. If there's a crowd around the picture and people are going, oh, wow, your orbital frontal cortex lights up more as you go up there. Unless you're iconoclastic, you go up and say, oh, that is beautiful. I see what you mean. So social context matters. And the most disgusting one for lots of you is that social evaluation matters a big deal. This is an actual painting whose value is $15 million, which it sold for. And if someone tells you its valuation in money, you're more likely to see it as beautiful. Not 100%, but it's true. One other thing, and I'll be done. Authenticity. Wow, how does that? Again, it's got to be a very well-developed part of your cortex. But this is, again, a top-down thing that says, is this authentic? What's that mean? Is it created by an authentic artist? And if so, people are overwhelmingly rate a piece of art as more beautiful, likable, valuable, etc. if an artist created, if they see that a person made it and that they're an artist, as opposed to they devalue it if it says on the what do you call it, the label, this is done by an amateur or a computer or an animal, a forger, a child. All of those decrease the beauty and by that token, what orbital frontal cortex is doing. And there's some examples to show. There's a real Rembrandt and a copy, and big difference, and they switch them back and forth. Depends. The one that, if they say this one's beautiful one, you like it better. If they say the other one's the beautiful one, the other one, forgery, beautiful, your brain finds them beautiful, depending on it not being a forgery. Just to finish that point, viewing of a portrait art elicited the predicted activation in visual cortex. In other words, visual cortex lights up because you're looking at something visual, and corresponding to regions sensitive to faces and objects, if it's something like the Mona Lisa. However, these areas were not differentially activated by the cue of authenticity. Okay, hope you're following me, but didn't matter if you said it's authentic or not. What happened in visual cortex, that lights up because it is an object, it is a face. What did light up, the only region activated by the assignment of authentic, was the orbital frontal cortex, which blah, 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 they go on to say. So orbital frontal cortex was the only thing that said, it matters to me whether this was done by a real painter. Okay, let me skip that over. And because I didn't spend much time, I'm just going to do the last couple slides to say that when Leonardo painted and when he made the choices 2 years in the making of that smile, he was painting clearly with prefrontal cortex, that he was intentional. He wanted to get that smile. He wanted an effect on your orbital frontal cortex. Of course, he didn't know what that was, but he wanted that emotional effect. And he spent his time making sure he would get that. What made it beautiful, what made it art, is that he did know how to paint with his prefrontal cortex, meaning, here I've called it medial prefrontal cortex, orbital frontal cortex. He knew that I need to paint with emotion so that my viewers will also have that emotion or an emotion like that. So it's much harder to study people who are painting than or to study people who are watching paintings. So we have much less to do, but not everyone, most people assume that to paint like a painter and to see an audience that you want to get to, you'll be painting with the same kind of cortex. By the way, we want to say that Malevich's Black Square, he painted 4 times to get it just right. Just want to show you how important it was for him to get it right emotionally 4 different drafts of a painting that is just a black square. So I want to conclude by saying it takes 2 brains to make art, the kind of art that Mona Lisa is. One is someone who knows how to paint with orbital frontal cortex, and I'm exaggerating here, who knows how to paint emotionally, and an audience who has the background and the desire and all of the things that go into what makes orbital frontal cortex smart. It requires really that communication between, and that, so part of what draws you to the Mona Lisa is wanting to know what the smile means, because you want to know, what did Leonardo mean? What emotion did he want here? And you're willing to spend a lot of your cortex to try to figure that out. And Leonardo bet that you would. Okay, I had some other things I'd like to talk about, but I've talked too long. So let me stop. I'm going to pull out of this mode. And I do want to just say one thing after a few questions about what has this got to do with humanism? Because I did think about that a little bit. But let me see if there's anything people want to be annoyed at or comment on so far.
There's if everybody wants to put their camera on or whatever, and just speak up if you have a question. There's a couple of interesting comments in the chat. JT Vanna said he learned 25 years ago, 2 different expressions from the Mona Lisa are processed depending upon the central visual processing versus peripheral. If you remember, he said, they say, if I remember correctly, if you look at her ears, i.e. peripheral, she appears to be smiling.
Yes. This is Livingston's work. Who's asking that? Someone knows Livingston's
Yeah, I
work.
actually, I'm sorry, I don't remember the details. It was, you know, when I was in college, and I attended, I think it was at the Institute of Contemporary Art when they were on, before they moved. And I was trying to remember, it's not the ears, it's somewhere you're looking in the periphery and you actually see an enhanced smile. If you're aware of, could you go over that just so I can, I think it was fascinating when I first heard that, but I've forgotten a little bit. Yep. Margaret
Livingston is a neuroscientist, did work on art at Harvard Medical School. And it's her work is showing that your eye doesn't take in the same information from all of its parts. And I don't want to get too deeply into this, but in some cases, it matters where your fovea is looking, what you're going to see in the surround. And that can dominate, I shouldn't say dominate. That can influence what affect you will experience as well, what it is you actually experience seeing, by what part of your visual field the smile is in, whether it's in the fovea or in the periphery. And so that has a big effect. I would say nothing is wrong with Margaret's work, and it's still part of the understanding of the neuroscience of art. But I would say that these things that I've been talking about have become a little bit more dominant. And they include her work, but kind of expand it to say, let's look at how actually it's this huge brain thing that creates beauty more than it is something that happens peripherally in the eyes. Because she doesn't have a good explanation for why the monetary value would be different, you know, depending on where it is in your visual field and so on and so forth. So nothing wrong with what she said. She was one of the first people to really study art and neuroscience, and a great both scientist and artist.
But if you know, I mean, I don't remember the exact location, but when we were in the auditorium, we actually, I wondered if just everyone here could have that experience too. If you recall, we were told to look at an area on, I don't remember what that was, because I just tried to do it when you had the picture up and I couldn't really get the right spot. You did see the what's the word? The emphasized smile when you look sort of directly away from it. But if there is a place on the portrait that we could look at, you know, and I tried doing it myself, I couldn't recall, and I was just kind of experimenting. Where is that spot to just to show other people? Because it was fascinating when I first learned that, and just to Maybe
So
share
here-
with the group.
Here's the thing. That like beauty definitely doesn't work as well on screen.
Okay.
You just think of it. What art
Okay,
is so
yeah.
much more vibrant and responsive to all of these effects. And that's why you should go to the museum. It's great. See, Margaret knew to have you actually see the painting. She didn't show you a picture.
Mhm.
So
Right,
anyway,
right.
let me just see what other questions I have. I can certainly go back and put that
Sure.
picture up,
Mhm.
but it
Okay, thank you.
definitely doesn't. It definitely will not work as well on the screen.
Hi, this is Tris. I also went to art school, and one of the things about the Mona Lisa that we were taught is that no matter where you move within the space, her eyes follow you.
Yeah. And he clearly painted very carefully, and lots of people do, to make that happen. And it's part of, I mean, I'm no artist, as you can tell, and no art historian either. But, you know, the little studying I've done, you appreciate more and more what Da Vinci was able to do. You know, just like that little thing about the background. Who would think that he would intentionally make something incorrect because he wants the effect of it on you, just like her smile is incorrect. But he knew what he was doing. And anyway, so I came away, the more you study him, the better he looks. And that's, by the way, that's proof of pudding of the things I was talking about at the end. Now, when I go to see a Leonardo, I see much more, and he looks much more beautiful because now I've been educated. And in fact, because I didn't talk about, and those of you who are artists know that he did exquisite things with paint that people hadn't done before to give this lustrous depth of paint. And that, you know, I don't have time and I don't know enough to talk about. You could give that talk. But now that I know that, when I go to a museum, I see more, and I see more beauty. I just go, oh my God, I see what he's doing with her hands. And I would have never noticed it before. So one of the lessons I don't think I taught very well here is that orbital frontal cortex is a real fast learner. It's picking up all of that stuff from the rest of your brain to say, in fact, your point about Martha Livingston to say, let's take into account how am I looking at this? And let me careful move and so on. And then you see, oh my God, her eyes are following me, all this. And in fact, a slide that I took out at the last minute was showing that when people are viewing a painting that they find beautiful, they move in front of the painting back and forth because they want to see its interaction with them. And there's a wonderful, research study showing people moving in museums around art that is completely stationary. Anyway.
I have a quick question for you, though. If somebody is an adult that loses their vision, is their brain capable of rewiring to, for lack of a better word, still see beauty without vision?
Absolutely. So my work, you wouldn't know, but my work is with people with disabilities, and I kind of had to cut that out. I'd love to, you know, I'm quite sure you're not going to want to have me do all this again. But anyway, if you really look across, good, you gave me an excuse to at least say one thing. Making someone blind, or in fact, the piece I was going to talk to you about was having someone who's face blind, prosopagnosia. Some of you may have heard of that term. There's some people who specifically, remember I showed you how faces are a little bit different than places and a little bit different than words. Some people just have a damage where the face part is. Everything else fine. So they would have a very different experience of Mona Lisa. They wouldn't notice any difference between her face and anybody else's. They all look the same to them, okay? They're just inarticulate about faces. So they wouldn't see the beauty in the face in the same way that other people would. They might see beauty in the whole painting and so on, because there's nothing wrong with their beauty. And wait, I lost track of where I was going with that. A blind person. So as you probably know, and we've done some work with museums around how do we give the experience of visual art to people who are blind? How do we make it tactile? I mean, completely blind. How do we create art that is just as beautiful, but is tactile. And it's its own field now to say, yeah, they have not lost anything about beauty. They've just lost one of the many pathways. In fact, as you may know, if you are blind early enough, more of your brain will become devoted to the other senses. Typically, people study audition, hearing. So people, some of my friends are blind, and they're exquisitely good at hearing and responding to sound, much better than I am. Because, and it's not just that they are kind of paying more attention in some stupid way, but in fact, their brain has enlarged auditory cortex. Or if in the case of food, it's enlarged it to say, okay, there's not any vision coming in here. We're not going to be able to see beauty. I'm making that a little stereotypically here with vision, but hey, what are my other senses? And the brain literally changes itself. It becomes a different brain. And if you look at the fMRIs of a person who is blind, especially early from birth, you'll see a huge auditory cortex. It won't look the same as yours and mine. It will be a big auditory cortex, and they're much better at picking up ugliness and beauty with their hearing than you are, because their brain is now specialized in a very different way. Does that make sense?
Yes.
Oh, I'm sorry, I forgot though. The great question follow-up would be, so is there any brain damage that does eliminate the beauty part itself? And the answer is absolutely. If you screw around, instead of with visual cortex or blindness, those kind of things that we just talked about, if what you do is you make your damage in whatever ways, chemically or technically, in orbital frontal cortex, people do not experience beauty in the same way. There you're going right after the beauty. They're not blind. They see all the colors, all the shapes, all the things. They understand them, no problem. And they move and know what's important to look at, all those things, but they don't experience the intense pleasure because that part of the brain is what's been damaged. And there was one thing I wanted to say, and you can do that with drugs. You can just damage, literally, dopamine, and they don't experience the same amount of beauty. And oh yeah, the funnest one is I hope some of you are psychologists, but I looked up because I wanted to know. Psychopaths and sociopaths have greatly diminished ability to have emotion too, like what other people are feeling, what they're feeling, and so on and so forth. I'm saying this poorly, but I think you know what. So they have a much shallower emotional experience with humans and humans' creations and all of that. And I looked up and, oh my God, I got myself deeply into it, looking at psychopaths and sociopaths describing their experience of art. And the first one I read, the person said that all of abstract art is just bullshit because there's nothing there. 2-year-olds could do it because she doesn't have the orbital frontal cortex that would allow her to empathize. This is a painter. They spend a lot of time. There's this whole history of art that I'm taking into account. Couldn't see any beauty in anything like that, even close to that. Certainly not Picasso, any of that. She thought it was all crap. And then I read tons of them, and they know, and they can hear people talk about it, say, oh my God, the way he does chiaroscuro, however you say that word. Anyway, and they go, yeah, I see it. He does that. And he does his paints really well, but so, and they just don't feel the beauty of it. It's not that they don't see it, they can move it and all of that, but psychopaths, and there's a whole, what do you call it, page on what's it called, Quorum. A bunch of people must be on it. Anyway, I'm sure there's a lot of humanists on it. Smart people gathered to talk about things. And anyway, a bunch of them, there's a whole psychopath, sociopath interest group, and they talk about art. Check it out.
David, we have a question from Shannon McCall.
Hi, I'd like to, if I may, I'd like to ask really quickly. I came in late, so I apologize. I just wanted to find out, whenever you see pieces like the Mona Lisa or the older paintings, when they go through a restoration and they do a cleaning on them, do you find that when they've been cleaned and some of the varnish has been taken off and some of the colors are more vibrant than they would appear as we have seen, like the Mona Lisa is very she's got kind of that yellow and brown going on. Do you find that when the colors are brighter or when we can see them easier, does it change the how people see it as being beautiful?
As you probably know, sometimes people find them not as beautiful as they were. There are people who go to the Vatican and so on who say, oh my God, that is way too bright. Doesn't look, unquote, doesn't look like the way he painted them. Because that beauty is subjective. I want to go to somebody points, isn't beauty subjective? Someone, Dennis asked.
Yeah.
The bright colors are great in the right context and for the right meaning and for the right purpose and all of that. And muted colors are perfect for entirely different emotional experiences and so on, all of that. And I just realized I'm way out over my skis. I'm not the person to talk about art. A lot of you know more about art than I do. But there's as many people I've heard were disappointed when they cleaned the paintings and in the Vatican ceiling, but also they're very worried about restoring paintings because some people will feel that they no longer look like what they loved when they first experienced it. But I want to use that as a jump point because Dennis asked, isn't beauty subjective? I hope you see that everything's saying that it is subjective. That is to say, it depends on your history. It depends on where you are right now. That is, are people liking this painting? Is people saying it's an expensive one? It's everything you've tried to paint in the past has given you a sense of what painting really is like. The things that are important to you are very different. So my point is that beauty is exactly subjective. The old view was that beauty is like the Parthenon. It's something out there. There are beautiful things. And I'm hoping you're taking away from me that no, beauty is in parts of your brain that are making it beautiful. Just like, remember I read the quote, color isn't out there. You make color in your brain and you make beauty. And one of the things I had to skip was, it matters what culture you're from. You don't see beauty in the same way depending on what culture you grew up in, or what family you grew up in, or what school taught you about art. All of those things are what makes art beautiful to you. And we're different. And we're just not the same. Even just experience. How many times have you viewed art? I can still remember the first time that an art teacher really did get to me. He had to drag me into a modern art exhibit because I thought it was all crap. I couldn't picture why you'd, look at a Nolan and a Litsky, Morris Lewis. They all look like, indeed, like the psychopath said. I hope I'm not a psychopath. They just look like my 2-year-old could do that. And it took an education, someone really teaching me about what that art meant. And so now I love those painters, just really different. So whether you have education, whether you have, are you from this culture or that culture, all of those things are subjective. So I hope I didn't mislead people. It's, someone followed it. So it's not in the eye of the beholder. That is the perfect thing. In fact, I had a slide. I don't think I want to open up the slides again, but one of the slides that I had was, it's in, beauty is in the eye of your prefrontal cortex. It's not in your eye. It's up there, way up front, where much more important things happen. And just to nail this subjective thing, it's your orbital frontal cortex and all of prefrontal cortex that is the place that is most you. Your visual cortex is actually quite a bit like other people's visual cortex. But the late developing parts of cortex, of which orbital frontal cortex is one, are the ones that are most quintessentially you, shaped by your environment, by your parents, by your schooling, by trauma. All of those things shape those late developing parts of the cortex, of which orbital frontal is one. So it's not in your eyes, and it's not in visual cortex. It's not in motor cortex. It's in prefrontal and largely orbital frontal cortex, which is the most personal, the most developed by all of your experiences, part of your brain.
So have there been any experiments done that try to separate out what we consider beautiful from the framing, the cultural framing that we are? I know that you can make people, you can, just by having a crowd go, oh, that's magnificent. You can see something in it that you wouldn't have seen before. You know, the story of the emperor's new clothes.
Right.
That exactly thing. People believe in what they're primed to believe in. Have you done some studies that show, are there things that are beautiful that we haven't been primed to consider beautiful? Are there some underlying things that are kind of very common, human considers that beautiful? Or do we know?
I'm trying to think how you could ask that question. Because by the time a person would understand the question you're asking them, their brain has already been shaped by their culture, by their parents, indeed by trauma, by expectancies, by beauty of various kinds, that I may not be answering your question, but I'm arguing here just the opposite of, so I want to really nail Dennis's question, that neuroscience would say that beauty is constructed. It's a personal construction. Brains. That's why I want that quote. Color is the same thing, even at a simpler level. So people are constructing beauty out of all of their experiences they've had, some of which are positive, some of which are negative, all kinds of things. But it's their emotional experiences that are key to what they're going to find beautiful. It's not the cognitive, oh yeah, I see that's perfect rectangle. And there's things about, perfect shapes and things like that. That's what's beautiful. But the more you look at it, the less that seems true. Whether a perfect triangle is beautiful depends on your background, depends on what you have been through and learned and loved and so on, rather than the triangle itself. But I'm afraid I didn't answer your question, Pamela.
It would be hard to do because you'd have to have things that people could look at that they hadn't seen before. So you could check to see which of those things that were novel they found beautiful.
Great. So if you, okay, so that's an experiment you could do. You could say, I've got a novel thing here, and I'm going to take it across many cultures and people who grew up with many kinds of experiences, and people who had disabilities, people who had bad dopamine systems, people who are blind, blah, 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 all sorts of things. And can I find something that most or all of them would find beautiful? Is there something inherently out there that we could find that would do that? Would that be a...
I bet a baby's smile, a flower, a bunch of evolutionarily pleasurable things. But what would be really interesting is then could you culturally change them by contextualizing something as beautiful that didn't start out that way?
Well, let's take a meal. It's beautiful to a baby right out of the nipple, and what the culture does is shape, well, what's the variety of things that could give you that same experience of beauty? So at the very beginning, that's why I'm saying, it's kind of hard to design the experiment, but nutrients are, in some way beautiful. But then cultures, Korean food would have a very different palate than, you know, American food, God bless it, in terms of what people would actually like. But that would have developed over time. You didn't get born to like American or Korean food. That was something that was shaped by your culture. But
It's like
babies,
there's certain universalities though. Across all the cultures, as far as we know, they all like music, do music of some kind. They all do visual, artistic things.
now
If I
that's
may,
that I just want to say that is exactly my view, Pamela, that music, visual arts, great food, those things, people in every culture do find some of those beautiful for sure. I mean, we are attracted to it, which shows the brain. In fact, you know, if I can say it, the neat thing about music and art, why I wanted to go through the whole brain thing, is how much of the brain you use to look at art. Remember, I went through all three major parts of the brain. All three major parts of the brain are involved in you experiencing art. It's a big, huge draw. And there's lots of people who say music and art are sort of the most demanding things that the brain does. And that's part of what is beautiful about them for us, because we like the challenge. It's like the challenge of the smile. That music, we don't like boring music. We don't like music we've, you know, heard all and over and again. We like music that's somewhat challenging, but it's a whole brain activity when we love it.
if I could interrupt, this is Shannon. I just wanted to add that you guys are talking about culture, and I'm glad you brought that up about art and culture. Because I've been very interested in the Black Madonnas that they have, I believe, that are in France. And I don't know if anyone has had a chance to ever see those, but they're very striking, and they're very unusual in the fact that by all appearances, they are what we would typically see in the art of the period of the Catholic Church, except they're Black. Yeah. And they've been, it's very interesting. And you guys were talking about culture. I was very interested in that because it seems like we're kind of taught to some degree what's beautiful and what's aesthetically pleasing to us based on our culture. And especially with events being as they are changing, I would be interested in knowing like your thoughts about like the future of the Mona Lisa, you know, as we continue to evolve in what we consider to be beautiful and become more diverse and more inclusive. What are your thoughts on that?
I think you've hit a big topic, and that is when I said in talking with Pamela, there's a lot of diversity within our culture in terms of what people will like, will grow to love, will grow to find beautiful. Our culture is very narrow, and it has subcultures, and people do not share the same sense, and that's where it's against quote subjective. What some subcultures in our culture find beautiful is not the same as others, and that again is not something we're born with. Like Pamela said, we're born with wanting to like music, you know, there's an attraction to music, but what kind of music is going to get shaped? And the white privilege predominating of art and music and saying, you know, all of the subcultures and all the cultures around the world, you know, the apotheosis of music is Western music. And the apotheosis of art is paintings like Da Vinci's, is in for a rough, what's the word? Coming up, and that we have damaged people, we've damaged cultures by saying your art is not as good as our art. It's not as beautiful as our art. And you know that people do that all the time. And I think that revolution has just begun, where people certainly swept through young people's art. Young people are much less wedded to culturally narrow art venues, art expressions. and more adventuresome. And us old people, myself included, I've already narrowed myself down to, I do go to symphony hall, you know, it's elitist white music. I worry about it. It's not sustainable. In fact, Boston Symphony is showing it's really hard to sustain it.
David, earlier when you started to mention humanism, I thought you were going to reveal that Leonardo was a humanist.
No, but thank you, Andy, was that Andy asked that? Yeah. So I talked about beauty, orbital frontal cortex beauty for visual art, music, great food. And I left out for the punchline the fact that when you see someone do a beautiful moral act, the same part of your brain lights up. You know, and I just thought that is perfect. When you say, you see, you know, actually, in fact, I forget who asked the question, but when you see someone do an anti-racist thing and you go, oh, wow, it's orbital frontal cortex lights up. Same beauty. Or when you just see someone doing something beautiful with their child, it's, you know, it's beauty. And I think so for when I think about humanism, the old kind of feeling good was following rules, authoritarian stuff. But actually, we need values. And that's what orbital frontal cortex is about. What are the values that art or music or acts can do? So when you see acts that have value to your culture, to you, you also feel they're beautiful. And boy, don't you remember some that I mean, I watch YouTube videos. There's some channels that are mostly, you know, about sort of beautiful things that happen when someone does something just gracious and wonderful to someone, especially who's in trouble or something. And I have to say, I too feel that, well, that was just like the Eroica, you know, I feel that way. So humanism, I think, is on a great track in that the old style, I do it because I'm told to, there's an authority up in heaven or there's an authority on earth that, and I follow the rules exactly, is not as powerful as having values. But those values, to tie up a bunch of our points, they are going to be developed. They're not going to be something we're born with. Wanting to get the values is something we're born with. And we have to have cultures that know how to teach those values and do it well. And to the question just a moment ago, we have to be careful that they are not one culture's values, because that's corrosive and highly problematic. So I think humanists are in a great place to say, we recognize that values need to be developed. They're values that are inside. They're not, they don't come from the outside. They're ultimately constructed, just like beauty. I should say at the end, beauty is just one of the values. There's other values, and they're going to be measured there. And what we want is people who have good values, not that they do it because they're told or anything like that, or they're religious or whatever, but have good values. And we aren't very smart about teaching that yet. And I'm in education, and I know that we don't teach values very well.
Apparently, we developed our big brains because we had to deal with each other. So our social interactions is, so there, and apparently there's underlying values that are human nature, sense of fairness, a sense of fairness, holiness. I don't remember the other ones.
Yeah, I won't be surprised if we use those words differently. Okay, I see Dean has his hand up.
Yeah, I had a question in the chat a while back. Is there an evolutionary reason we developed the beauty function in the brain?
Yeah, there's various people smarter than me that are, it's a big issue in evolutionary biology. As you probably know, why do peacocks have beautiful feathers, etc.? Is it you, etc.? And how does it? All kinds of arguments. I don't think I want to do that. Because you're asking the question, you probably know that literature, and it's a big literature. It's really costly for peacocks to have huge feathers. And is it just that they get better sex? Has been a big evolutionary debate. Re-say your question, Dean, because I think I went off track there.
Okay, I said, is there an evolutionary reason we developed the beauty function in the brain? And I guess I know about the peacock, but we're talking about something more abstract here with music and abstract art. And I'm wondering how that might have evolved.
So I think we evolved to have values, and Pamela, you mentioned this, to have values that are social, that they're part of our group. And that can be bad in that means there's an out group often. But anyway, values are what keep communities together. So it made humans be, what's the word? Effective. Yeah, that we could collaborate. We cooperate. We did all those things. So social values are big. And as you probably know, in fact, a study I wasn't even going to think about talking about was someone did a study of people on first dates, what they learned most about each other from asking. And they argued that the most illuminating question was, what kind of music do you like? Isn't that interesting? And you think, well, that's preposterous. But actually, my own son, who's 40-ish, met his now wife online, and they were at the first date, and she clearly thought Nick was kind of hokum. And she said, what kind of music do you like? Because he was sounding too good, I think, you brag about yourself. She says, what kind of music do you like? And he said, and he was like, he's Harvard Law School and that kind of, like effete. And she says, what kind of music do you like? And he said, country music. And she said, bullshit. And she said, show me your, what do you call it on your cell phone? Show me your music list. And he pulls out his phone and he shows his music list, and it is country music. And she goes, oh my God, I don't believe it. And now they're married. So music is a part of the cultural and personal connections that is very important. And by the way, there's lots of studies showing that people that sing together, they really, there's a euphoria of singing in a choir. Same part of the brain lights up. Singing with people is different than singing all by yourself. And music ties us together in this beautiful way because we are sharing for that moment the value of this piece. I want this piece to be beautiful. And so I think beauty came out of that whole thing of how do we create cultures that love, respect, share, cooperate with each other. And music and art is one of the things that can bind us together. And the danger, as the woman pointed out, is it can also exclude some, say, we don't like people who don't like art like us. And that's where it gets scary. And that's where humanists need to play their role. Anyway, I feel like we've gone on too long. I'm not in a hurry, but I think everybody should know that you're very welcome to leave. And Andy, you may want to pull the plug.
All right. Well, I think we've had a very interesting discussion, and yeah, I think we've all learned some things. I have to look at that painting again some more now, Mona Lisa. So thank you, David, for your talk. It's very good. And I will be posting this on YouTube. I have to view it. We did have some dropouts on the speech. I don't think they were too bad, but I know some people might be disappointed, but we'll take a look at that. I'll play it again to make sure it's all right, but I'm assuming it's okay. So I'll say thanks again to everybody for showing up and for the talk and your questions. And we'll see everybody next month.
Have a good time. Bye-bye.
Thank you, David.
Thank
Thank
you.
you.
Good night, everyone.
Thank
Good
you
night.
very much.